All right. So I'm going to go through uh, the process of setting up the character inside of DAZ 3D. I'm not going to go into all of the details. I'll probably give you a heads up of a sort of outline of what I'm doing, but I won't go into the details. I want to focus on setting up the character for use inside of DAZ 3D, and then give you an overview of how you can set the characters up inside of Unity and what the different functions are for getting animation to work through facial recognition inside the software. Um, like I said, I'll touch on a lot of the details, but I won't be going into anything that's not directly relevant. I'll reference it to give you an idea in case you want to move forward and ask some different questions if you do decide to do it. But I'll try to focus on just the relevant stuff so you can see if you want to do it. So anyway, let's get started. Okay, so as you can see here, we have the 3D character. I already put some clothes on. As I said, this is the easy part. You just get your assets. I can teach you how to import all that stuff, how to change the different parameters to make the character look the way that you want it to. But really, it's just dragging and dropping. If I wanted to change the hair, I would just select the hair, and I just drag and drop. Well, actually, you don't have to drag and drop. You just double click. And it'll update it and change it. So yeah. So once you have the character that you want, and once you have your configuration the way you want it to, you're going to use something called the you don't have to, but there's a great resource from Realusion. They work with iClone for creating resources for animation, and it's called the iClone Face Key. It's a DUF file, which is, I don't know if it's specifically for DAZ 3D, but I see it a lot here, and I haven't seen it anywhere else. So you'll take this key and you simply let me just have first selected. You take that key and you drop it onto your character. Now, what this is going to do is it's going to add animations to the character for any number of things. In this case, with the iClone, it's for the face, so it's like different vowel sounds that you can do, or expressions. With the iClone Face Key, it's primarily focused on vowels, but I'm going to show you some other animations that you should export to if you decide to do that. So it's going to ask. It says you don't have to worry about this. It says the length of the frames are beyond the timeline. It doesn't matter because we're not using the timeline inside of iClone or DAZ 3. We're going to be using the blend shapes inside of Unity. So click yes. It'll take some time to load. And there you have it. The animations that you need to for use inside of Unity are on your character. It's as simple as that. Next part's a little bit more tricky. You're going to export the files. I have a folder here already. This Opencv folder. I don't know why I called it that. Call this just Opencv. And we're going to make sure that it's FBX, because that's the type of file that works really well. It gets the rigging and the materials, the textures, everything, and most importantly, it gets the animation files for your characters that you're going to be using. So we're going to go ahead and click Save, and you'll just want to copy this. This can be a little bit confusing. I kind of got into the weeds and how this stuff affects the export of the models, but this configuration works best for me. Now, the important part is choosing the animations that you need. I have garnered a lot of different animations and morphs and all that kind of stuff over the years, so mine is pretty extensive. I'll show you. Um, just the character is Libby, is the one that I'm using. Just for this character alone, there are a ton of animations that you can use. So, it's extremely extensive. So what you're going to have to do is filter out the animations that you want to use. And a good thing that you can do is you can reference a collection of particular animations by using their um, a portion of the title. The ones that are categorized together, you'll see after the Genesis 8 female, which is the figure that I'm using. There'll be a little like key or marker, an acronym. So P control the arms, uh, dot Molly, that's for the character Molly that I have, and so on and so forth. So you can use a portion of the name to reference a collection of animations, and in our case we're going to be wanting to use let's see, there's a lot of animations, and if we were to use all of these animations, the export would take hours, or if you upload it into Unity, as you'll see in just a second, you'll have to sift through hundreds of animations to get the ones that you want, which can be a bit of a hassle. So the ones that we want to use are I believe it's ECTRL, E-Control, which references facial animations. Just going to try to find these here. Oh, maybe I skipped them. I know they're ECTRL, but I want to just show you how I'll use these. Just go. Here we go. ECTRL, and you can see that it has the little marker ECTRLV of the enunciations that are part of that animation. So T would be the T sound, so the animation would animate a T. You have the ER sounds, which would animate a sound or whatever particular animation that would be. And then you have some pretty basic ones like just a smile, mouth open, frown. These are the kind that we're going to be using. So we're going to do ECTRL inside of our morph rule, and we're going to click add, and then we're going to type in dot E CTRL. I'm not sure, but I'm pretty sure that the capitalization matters. So you're going to want to make sure if it's lowercase, it's lowercase, uppercase, uppercase, so on and so forth. So we have that set up, and the animations are going to be baked into the character, and we're going to accept that, and that will filter out the animations that we want moving forward. And now that we have that, let me just double check something real quick. Okay. Now that we have that, we're ready to export, so let's do it. So we're going to click accept, and it's going to get started here. It might take a little bit, so especially with I'm running Opencv and I'm using Droid Cam with my phone, so it might take a little while. I could have probably filtered out more of the animations, but let's just see. If it takes too long, then I'll have to throw this into Premiere and edit it. So hopefully it doesn't take too long, because it's probably going to take 2 3, so I'll probably edit this part out. And sometimes if you try to import a character with too many animations, it'll just freeze up and it'll crash Unity. So, and by the way, I guess it's good to note that you can see here that a lot of them are like ECTRL mouth, and it'll be M. So you can type in ECTRL M. You can type as much as you want to filter out the animations that you want exported with your character. Another good part about these animations is It doesn't just have to be facial animations. It can also be full body animations that you can move. Now I haven't worked, as I said before, with the hand tracking, but if it does, that would be really, really cool. And another quick side note, the beauty of blend shapes is it really cuts down on the you know your CPU and GPU usage. I guess more CPU usage, because instead of animating the joints and their parameters, which would have to do a certain level of calculations and things like that, they're pre-rendered animations. So you're effectively turning dials and knobs inside the the processing centers of the program. So it's and it makes it a lot more simple. You don't have to do your own animations. You don't have to you can section off the animation so that you're only using portions. Like if you want to just do fingers, you can do fingers, hands, wrists. There's great masking tools inside Unity too, so it really is a robust resource. Okay, so I had to pause because it took, no exaggeration, probably 20-25 minutes. I'm sure on your device, on your computer, it's going to go a lot faster. I've been having to work on mine, or I should have worked on mine a long time ago. But anyway, so as you can see here, I've already dragged the character into the project. This took a long time too. Exporting took a long time, and then dropping the character in and having Unity recognize and import it took a long time. But let me see if can I move this? Yeah. So the character's in here, and you can see that this is the character and this is the model. Let me just minimize this. I'll put you back over here. There's a few things that you're going to have to do before you can use the character and even start animating. The first thing that you want to do is you want to go to the rig of the model, and you want to make this a humanoid character. That'll take all of the imported rigging from the figure and make it compatible with the skeleton that they have inside of Unity, and I'll show you what that is in a second after we do that. So you just select humanoid, and you don't have to worry about that. That's if you have another model that already has rigging that you like, you can make it compatible with that setup. And then you click apply, and this might actually take a little while too. Let's see. Yep. Just make sure. Yep. Okay, I'm back again. It took a really long time, so I decided to pause the recording inside of OBS. But so yeah, so it just finished configuring the bone structure to be compatible with Unity. I'm going to go into the configuration tab in just a second, but there you'll see how the rigging is laid out and where the bones go, I guess in correlation to the DAS figure and the way it's originally rigged, and how the rigging is kind of approximated inside of Unity to make it functional. At a later date, I might actually go into like DAS 3D and show you how you can change the rigging and actually rig figures in there, or I might try to do something similar inside of Blender, or show you how to like remap textures inside of ZBrush. But for now, we'll just focus on Unity. So yeah, let's go into the configuration tab. And here you can see the bones. Just select the figure of the character. Okay, yeah, here you can see the rigging and the bones. It's kind of jittery, so it's kind of hard to get a handle on it. Bear with me 1 second. Okay, so you can see here are the bones and how they're rigged. Usually I'll go in and just to make if I'm animating a character or applying animations, um, like mocap animations to a character, usually I'll go in and I'll edit the bone structure just to make it seem a little bit more fluent. Not really gonna have to worry about that right now because we're just worrying about the face. But here is where you would edit them. You can, delete the different bones they have on here. You can change the bones. Sometimes if you get a character from different resources online, I'm blanking on them now. But if you get different figures, they'll have different bone structures, and not all of them are out of the box compatible with Unity. Let me see. Pose. Like you can change it to enforce the T pose, which is the default pose. It's supposed to be the default pose for the character. I might actually just go ahead and do that now. And see, it'll fix a lot of the bones in here because the way that the interpolation of the movements are set up inside of Unity, they're all based off of certain references to the the 3D space, the quaternion space of the bones, so that the animations can then look appropriate. If they weren't configured perfectly, then an arm that should be here might be up here or down here or back here. So we're not going to get into the weeds about that. I'll try to keep it short, but we'll go ahead and apply that. And I might have to pause again. Oh, jeez. Computers, it's not a bad laptop, but I'm sure you're working with something a lot better, so don't think it'll take this long. Okay, back again. That took a long time too, longer than it used to, so I need to check out what's going on my computer. But anyway, so Unity finished configuring the model. It set up the rigging appropriately. Probably didn't need to do this now, but I guess there you go for posterity. Just to show you, you have a resource where you can configure inside of Unity, which is great. Configure your model and its rigging and its skeletal structure right inside of Unity, which is great. So now that we've done that, let's back out of here. And now we're back in. There's some things that you might notice on the character right out of the box. This is something that is somewhat particular to Unity, but you can see it's kind of hard. It doesn't really let you zoom in right here, but I'll show you more detail in a second. Like the eyes are white and the eyelashes they just look like blocks. You kind of have to go in and configure the materials on the figure so that they can look the way that they're supposed to. But I guess I'll show you what that's like. So anyway, let's go back into the project. We're gonna select, we've got our figure here, and as far as showing you how the code and things affect the character, I'm gonna use the one that's already in here because I have everything already mapped up with this figure, and that would take a really long time. But I'll just show you. Let's bring her in here. I guess we'll place her right here. And let's go to her. Here's the shape, and here you can see all of the animation morphs for the character are loaded in, and these are what we're going to reference in our code. Like I said, I'm not going to get into the weeds of the code, but I'll just show you what portions of the code are affecting the character and how, just so you can get a sense of how the function of creating your own VTuber type character facial animations actually works. But to show you, I'll do a face animation now, so you can see. Like we'll do one for, I guess, something that'll, if you adjust these parameters, you can see them change on the character, and those are the blend shapes that we're going to use to animate our character with Opencv and the dlib library so on and so forth. So just put that back to 0. And I'll show you the code that I'm using to do this. We're going to go into the character and the program, the code that's used to animate it in real time. So, and I haven't forgotten about the textures. I'll show you that in just a second. So here you can see I use the Unity Chan CV VTuber example. You can find this on the Unity store. There's also analogs to Opencv programs, I guess APIs that you would attach to the program inside on GitHub or different resources online. But the part that we're going to be focused on is the face blend shape controller. I'm not going to get into the head or the neck rotations or anything like that, because I think this will serve as good enough of an example. So here's the program or the code as a resource in the inspector inside of Unity, and inside the inspector there's references to these variables which hold the different parts of the character's body that we want to reference. And in this case, we're just doing the head, so we're going to reference the entire female Genesis 8 female figure, and attach to that figure inside the FBX or all the animations. So this code is going to reference those animations and manipulate them based on the data that we're getting from Opencv. So let's go into the code so I can give you a better example. And of course there's other parameters here where you can adjust the sensitivity, and it says leap here, but it's actually the lerp. It's an interpolation of the 2 points that it's moving between to control how smooth or how rigid. Because my computer's not particularly fast, I have these set pretty low. The sensitivity is pretty high, which means that any movements when it reaches a certain level will trigger the animation to just move to the particular animation. So if it's a mouth open, it'll move right to the mouth open. If it's eyebrows, it'll move to the eyebrows. And I'll show you an example of that in a second. But let's go into the blend shape controller. So here we have the blend shape controller script, and here are the variables that I mentioned before that were inside of the inspector, and you can have as many of these as you want, any combination of them as well. But you create the variable here, and the variable, you give it a name. I just use these as reference points, and then you can set the range for how much of or how large the variable you want to be. I'm doing mine from 0 to 1, so I would use what's called a float value, which is it's basically a decimal point. So it can be anything from 0 to 1, or anything from 1 to infinity at each decimal place. I believe the decimal place for floats goes up to something like 8 or 9, and then you have to use another variable. I forget now, but anyway, so you set the range for the variables, and these are the parameters and the lerp variables for controlling the smoothness and controlling the register for the for how we're going to interpolate the data from Opencv. And then if you go down here, you can see this function actually controls the animations on the character. So actually, let me turn this light on, because as you can see, it took all day to do this. I'm gonna turn the light on real quick. Got dark. Okay, so if enable, this variable basically says the data that is being read now is different from the data that's read before. All of our blend shapes are controlled by the if else statements inside of this function, the face blend shape update function. And so if the data we're getting from Opencv is at a certain point, like if it was to register my face and my mouth reaches a certain point, the animation would trigger that blend shape at that particular point. Same thing for the eyebrows. You can see the eyebrows here. There's a variable. And the if-else statement that we have in here, like, I'm not getting into the weeds of it. I just want to give you an overview because there's a little bit more to it, but I just want to show you, just so you have an idea of how it works. The first if statement says if it's between if it reaches 0.99%, which means it registers the value of the mouth being open by 0.99%, then it'll trigger the eye open variable that we saw before to animate up to 0.7, so 70%. It'll open, the mouth animation will open to 70%. If not, then the mouth is closed. I could do that for 100 different types of configurations on the character, animation types and configurations for the character. But for this part, I decided if my mouth is open sufficiently to a certain point, it'll animate to 0.7, else it's closed. On the eyebrows, I think, I set 2 levels. So if it's 0.95, then it opens fully, to 1. If it's open to 90, the value is 90 that we're getting from Opencv, then it'll go to 90%. Or else it'll be, the eyebrows will be, where they normally are, their original location. That's just to show you, you can have multiple levels of each animation too to trigger certain points. Some of the animations are really good. I did this a while ago, but there's a lot of new animations and stuff you can do, or you can make your own animations inside Blender and bring them into your characters. Where if you trigger a smile, it'll read those points and it'll lerp to a smile. You see that in programs like FaceRig and things like that. I've never really gotten that far because I started doing my own game, MIDI Box, which took up all of my time. So, but it's something you can do, and if it's something that you decide to try to do, just ask me, and I'll be more than happy to show you how to make your own full-fledged figure. As you see here, there's a function for, or if-else function for the mouth. Opening this way, there's one for it opening this way, sideways, so X and Y. And these are all controlled by these functions down here. These functions, basically, everybody's face is different. The location of the points on the face where the data points correspond to are going to be different. So if you have somebody with a really long face, their data points would register low at a different coordinate. And if it was just flat across the board, then someone with a long face might, always trigger a frown, or someone with a short face might always trigger a smile or open mouth. Somebody with eyebrows higher, so on and so on and so forth. These basically take the data points and interpolate them based on other points on the figure. So, for example, actually, I might have a picture. Let me see. I think if it's still in my downloads, I should have had this prepared beforehand. But I actually do have it. Great. So let's see. It's taking a while. Sorry about that. So let me make sure I'm still. Okay, good. I'm still recording. Here you can see this is the setup for the face landmarks that the program is recognizing. So as you can see here, each of these values correlate to the values that are being registered by Unity. So here it's using points 46 and 44, 46 and 44, and it's also interpolating the points 27 and 30, which should be 27 and where's 30? 27 and 30. uh, oh, right here. So these 2 points here, 27 and 30, and it's also doing 46 and 44. So, and this is for the eye open. So it'll interpolate that difference and create a range, and the median range between those points will correlate the distance that it's moving from those 2 points. It's kind of hard to explain, but that interpolation of that data, the distance between those 2 points, is what gives you an average. Basically, they're taking the average distance. So you can have an average between 100 and 3, or you can have an average between 700 and 2. But it'll round that data out so that it can be applicable to the actual face of the individual, not a generalized value. Because to go in a little bit of history, the reason why Opencv and the DLib library in particular are so great is because the person that made it, there's lots of documentaries and stuff out there about him. His name escapes me, which is a shame, but the person who made it, and then subsequently the people that got involved with the project, took a wide range of faces and they added it to the library and used artificial intelligence to be able to recognize data points on the face. And I'm not going to get into the weeds about that because I'll be talking for hours, but basically that huge library can point to the individual points on the face, and you'll see that when I start the program up here in a second, and create markers for data that can be used in anything from street cam recognition for people walking down the street, for you see a lot of time the artificial faces where people change their faces, and applications, the mask, all that stuff. It's limitless, but yeah, so that's just a little posterity for you. But anyway, so it uses these interpolations of that data and their coordinates in virtual space to then take those correlations of data and apply them to the character. And they have those, right? I mean, you can do these for anything too. You can do this for, we were talking about hands. You can do this for, the body, the legs, everything. That's why they have. This is how they were able to develop markerless. The DLib library and Opencv, the CV stands for computer vision, is how they were able to develop the markerless mocap, or how it's even possible. You can have marker mocap, which basically registers, the depth and the coordinates of the points on the person's face. They're using contrast, which is another side note, how they originally interpolated the large data set for the DLib library. And they use those data points to manipulate 3D figures for things like movies and stuff like that. But with the technology they have now, it's still used widely, but for general use, like being a VTuber, things like that, Opencv works really, really good, especially if you don't have a slow computer like I do. So anyway, so now that I guess you have a general idea, again, I apologize. I wish I could go into more detail, but you only have so much space to record on the computer. Of how the code is functioning, interpolating the data, and applying it to the figure. Let's go back into the figure. What I'm going to do is I'm going to get rid of her, because as I said, I haven't set this up for this figure, which is basically just taking the figure and dropping her blend shapes into here. I haven't set that up, and there might be slight differences because the models are slightly different, but I'll go ahead and get rid of her, and we'll show you how this works inside the model. Let's see, let's go to her figure, and now I'm gonna have to turn off the camera inside of here so that it can be registered inside of Unity. So bear with me a second. Actually, I haven't done this yet, so I hope it works. Hope it doesn't just freeze up. Okay, and we're in, and it's very, very, very glitchy. I'm going to turn her around a little bit, face the light so we can see what we're doing here. Alright, we're zoomed in, and you can see my face here, and it's recognizing all of those points. And if I open my mouth, you can see, let's exit here. Let me move it over to, there we go. You can see the value changing here. I'll just choose this one as an example. That's the mouth. So it's registering the points that it's getting from Opencv, and it's applying it to our script so that we can move the blend shapes that we imported from our characters, the same as the other model, inside of Unity. And it does the same thing for the eyes. Like if I close the eyes, I don't know where the variable is on here. Let me see. Okay, yeah, there's the eyes closed here. So when I close the eyes, it changes the value. And the mouth, changes that value there. And then there's also some other animations that I have in here. Now, these animations for the head and neck are not part of the blend shapes. I'm actually, I'm not going to get into that code now, but I'm using the actual geometry. I'm animating the actual geometry. So I set the values for, the character's location in space to the actual 3D movement of the figure in Unity, as opposed to a blend shape, which you can do. I also did the same thing. I don't have the guitar set up now to show you how this can function with MIDI, but you can do the same thing with MIDI. So I was sending MIDI data to Unity to control the figure, the fingers and the hands. I have that on other videos in on the YouTube, so I guess I'll link you those as well. You can see the eyebrow data here is changing. The face isn't squared up and the light isn't perfect here, but it gets the eyebrows. And I have a lot of facial hair too, which isn't great for Opencv. But that's pretty much it, to be honest with you. I'm probably blanking on like 10 or 100 other things that might be relevant right now. But that's essentially how you set it up. You take the figure from, or you select your character, build your character inside whatever program that you're using, inside of whatever program that you're using. So you take whatever figure you have. That's pretty much it. You just take the figure, you build your figure inside of Blender or inside of whatever program that you want to use to build up figures, or you get the figures from a resource like I did, like Daz 3D, and you export them from your modeling software, and you make sure that first make sure that the animations are attached to the figure. You create your animations or select the animation that you want. Another quick side note: there are great resources in Unity now for building animations directly inside of Unity. Some really great ones, and actually, what's the name of the animation program? 3D is it called 3D Motion? Let me see. What's it called? I might have it in this. Let's see. I guess I don't have it here. Oh, it's called U-Motion. There's a program called U-Motion for creating animations inside Unity. There's modeling programs. Pro Builder is the best. It's great for making quick models. And yeah, so you get you build your figure, you build your animations, you export the figure, of course, with the animations, import them inside of Unity, and you do slight configurations to make things work appropriately to the figure, to the materials, and to the skeleton. And then you use the animation library or the animation code inside of Unity, configure it to your liking, affecting whichever blend shapes you decide that you want to animate using Opencv, and you're good to go. I mean, it's really I'm making it sound. It isn't that complicated, but I'm probably making it sound a little bit simpler than it really is. Once you're familiar with the code, it's really as simple and as easy as changing the parameters to your liking. If you want me to go into more detail, I would be more than happy to. If this is enough for you to get started, because it might be a lot of information, then let me know. But it's really as simple as that. Yeah, so let me know if you have any other questions or you want to know anything else about it. I'd be more than happy to talk about it. All right. Talk to you soon.